This may look familiar to you, hopefully it does. This is the topology that we've been using throughout some of the lessons that we've just covered. And what's important about this topology is it's really easy to replicate. And you'll notice this from this course is that a lot of the topologies that I like to use are some things that you could pick up real easily, replicate, or utilize something like CML or a packet tracer to be able to replicate the environment and be able to get these things working. So here we have two switches. They're just going to be connected back to back, and what we're going to do is we're going to make the link between them a trunk link. We'll notice that we'll have two devices as far as host PCs that would be in VLAN 10, and then two IP phone devices that will be in VLAN 20. And the whole thing that we're going to show here is that you can have separate VLANs for each type of traffic. You can consolidate those and allow them to pass across between inter-switch links via trunking. So you can have that VLAN 10 and VLAN 20 flow across that trunk between the two switches, as well as we're going to have some layer 3 VLANs to be able to do the inter-VLAN routing that we had chatted about. So you'll have a layer 3 subnet and IP address for VLAN 20 on both switch 1 and switch 2, as well as a layer 3 VLAN interface with a separate subnet for VLAN 10 on switch 1 and switch 2. And we'll show how all that works. We'll be able to add and remove VLANs from the switch. We'll be able to add and remove VLANs from the trunk. We will also be able to change which VLAN we want to be native and pass untagged traffic back and forth between switch 1 and switch 2. And then we will build upon this topology for our next lesson. All right, here we go. All right. We are going to cover in this lesson the trunking attributes of 802.1q trunking that we were talking about, as well as what the native VLAN does for a trunk link, and how do we specify VLANs per port, configuring them for both data and voice VLANs, and how do we change the default VLAN. So let's dig in. Let's start off by first going to config T, getting into global configuration mode. And what we're going to do now is we're just going to add some of these VLANs. So in this particular case, we've been working with VLAN 10. We're going to name it data. So it's our data VLAN. We're also going to specify VLAN 20, and we're going to hit enter, and we're going to name it voice. Now, one thing I do want to call out, if I were to go do show VLAN brief, you can see that VLAN 20 is not there yet, but VLAN 10 is. The whole reason is once you're in the configuration mode of a VLAN, if you don't hit enter or get out of that, you're still in that configuration sub mode for that VLAN. It doesn't commit those changes until you get out of it. So for example, if I type in the word exit now, and then did show VLAN brief, you see that we have both VLANs now. Just something to keep in mind that while you're in the VLAN configuration, you have to get out of that before it shows up in actual VLAN database on the switch. And to see the VLAN database, you would just do show VLAN. Now we have two configurations done. We have two VLANs created. You see that over on this side, there are no ports in those particular VLANs right now, which is fine. What we're going to then move forward and do is we're going to look at configuring interface gig 0/2 as a trunk. So if I were to go do show run interface gig 0/2, right now it's set up as an access port, and it also has span tree port fast enabled. So it bypasses the listening and learning state, goes right into forwarding. Not something we need right now because this is the interface that is connected to the other switch. So for example, what we'll do here is we'll say description, and we'll call it switch to uplink. And we'll just throw some things in there to make it look pretty so you can see it. Now what we'll do is we'll say switch port mode trunk, which I should spell that out for you. Switch port mode trunk. And if you do that, what it does is it changes it from an access port to indeed a trunk port. So now that we've typed in switch port mode trunk, it's set up as a trunk port. Now, in previous versions, we used to have a switching trunking protocol called ISL, or inter-switch link, and then we had 802.1q. And in the previous versions of iOS, you would have to say switch port trunk encapsulation, and you see now that that doesn't exist anymore. So you would say switch port trunk encapsulation .1Q to specify it's a .1Q trunk, because by default in the past, ISL was a Cisco proprietary trunking protocol, which was enabled by default. So you would have to specify the encapsulation type of .1Q. You no longer have to do that on these newer versions of switch code, which is good to note. So the other thing is, so we have switch port trunk, and then we have a couple options. I'm going to hit the question mark to show you the context sensitive help. Some of the things that we were talking about are allowed VLANs, switch port trunk allowed VLAN. You have to then specify the numbers of the VLANs that you want to flow across that trunk, which we know in this case we need 10 and 20 at the minimum, right? You could also say switch port trunk native VLAN. And if I hit that, that's where we specify what other VLAN we want to be the native VLAN in that list of VLANs. And then there's pruning. Pruning is essentially trimming off VLANs that are not necessary on that particular link. We're not covering pruning right now, but we will when we get deeper into the trunking discussion. So let's see here. Let's say switch port trunk native VLAN 100 based on the example that we've been using. I'm gonna hit enter and show you what happens. So now that that's configured, if I go over here and I say do show VLAN brief and hit enter, you'll notice something. VLAN 100 doesn't exist. I called it out specifically as a native VLAN, an untrunked VLAN, but it doesn't exist. So we still have to create that VLAN. The other thing is that if I go do show run interface gig 0/2, then you can see that this is a trunk that is uplinked, and you could also see that there's a native VLAN 100 on it, showing that we have the port set up as a switch port trunk, and we have the description configured as well. So what we're going to do here is, one thing I'm really wanting to do is remove the spanning tree port fast edge configuration. We don't need that on here at all. So then now that we have that configured, I'm going to go ahead and say VLAN. This is another cool trick. VLAN 100. Notice I'm on the subconfiguration of the interface, but that is a global configuration command. If I hit enter, it jumps me right into the global configuration mode for that VLAN, and then I could just say name, and we'll call it native, just because that's what we want to call it. Now that we have that, if I end and I say show VLAN brief, here, show VLAN brief, you can see that we have these VLANs created. Now, what I'm going to do now is show run int gig 0/2. We can see that it is set up as an uplink. We can see that it has the native VLAN of 100, and we see that it has the mode trunk. Now, if I real quick were to go show interface trunk and hit enter, we can see the gig 02 is a trunk. It's mode on because we statically set it to a trunk link. It's using 802.1q encapsulation. It is indeed trunking, and the native VLAN is now VLAN 100 instead of VLAN 1. However, if you look here, it says VLANs allowed on the trunk. They're all allowed because I didn't specify a VLAN. So every VLAN that we have created will flow across that trunk. Now this says VLANs allowed and active in the management domain. 1 was the original default VLAN, which we had created by default. It's there. 10 and 20 is the data and voice VLANs, and VLAN 100 is the native VLAN. So every VLAN that we have created so far is allowed in that management domain. We can prune those off or only allow specific VLANs on the trunk link. We'll do that in just a second to minimize the amount of VLAN traffic that's going back and forth on the trunks, that if we don't have something in that VLAN on the other side or a device in that port that's in that VLAN, then there's no point in carrying the VLAN over the trunk link. And then finally, we see that there are 2 participating in the spanning tree forwarding straight and are not pruned. Now, we do not have anything set up for spanning tree as far as that goes yet, so I will show you what that means when we get into the spanning tree section. But that being said, let's go back to interface gig 0/2, and we're going to say switch port trunk allowed VLAN, and then we have some options here. Now, we only want to allow VLAN 10 and 20 in this particular case. So what I'm going to do is say VLAN 10, comma 20. And if I do that, essentially what you'll do is you'll notice, I'll hit enter. I'll go do show int trunk, And what it did was it trimmed off VLAN 1 and 100 off of that link that we did not want. We only want 10 and 20. And that's because we only have devices in VLAN 10 and 20 on each side of this link. Now that we've configured switch 1, let's take a look at switch 2 and what we have to do to make sure that everything's working on both sides of this link. So here, if we do a show run interface gig 1/0/2, we can see that the link between switch 1 and switch 2 is configured. We see that there is a description of switch 1 uplink. We see that it is a native VLAN of 100 and that we are allowing only the ports of 10 and 20 across that link, and that we have statically set the switch port to a trunk mode. Now that we have that, we can simply do this and do show run interface VLAN 10. We have a layer 3 VLAN for VLAN 10 and SVI, or switched virtual interface, with this IP address of .25. And now that we have that set up and we know that our trunk is set up, let's do a show interface trunk. And we can see that we have, again, 802.1q encapsulation on that gigabit 102 interface. The status is indeed trunking, and the native VLAN is 100. Again, only allowing these VLANs. So based on everything that we saw, everything is functioning and working. So now the true test is to see if we can then ping the far end SVI, and we can. We see that we meet with success. We are able to ping from the SVI of VLAN 10 on this switch with the source address of .25 to VLAN 10 on the far switch, which would be switch 1, with a IP address of .26. So that is how you configure ports for a trunk, as far as allowing certain VLANs on 802.1q trunking. We'll dive a little bit deeper into some trunking here again, but this is for the most part what you need to understand as far as how to configure trunking and what commands you could use to validate that the trunks are indeed working. And if you do a show VLAN and hit enter, you get information as to what VLANs are active on your switch. And then as you see, there's some more information as far as MTUs and things like that. That's why we typically use the show VLAN brief command, and it just only shows the VLAN list. And there you go. VLAN 10, VLAN 20, and native VLAN 100.